Hi, everyone, and welcome. My name is Lata, and I'm from the FGD Trion team, and thank you all for joining us today. So let me start with a maybe practical challenge. So in renovation and asset documentation and construction, one of the hardest questions is often very simple. So what exactly exists on site today? And drawings may be outdated, access may be difficult, and project teams often need reliable existing condition information before they can start design or do any planning. So in today's session, we will look beyond scanning as a standalone technology and focus on the complete workflow: capture, processing, interpretation, modeling, validation, and delivery. And before we begin, let me quickly introduce our today's guest. So joining us today is Mehdi Boroumand, the geospatial and reality capture expert in Australia. Mehdi has over 30 years of experience in surveying, mapping, and geospatial innovation. And what makes today's session valuable is that Mehdi's practical user-side perspective is really very valuable in terms of sharing different kind of cases. So he will share how reality capture has evolved, what common misconceptions still exist, and how capture data can become reliable deliverables for design, renovation, construction, and assets workflow. So welcome, Mehdi, and it's great to have you here.
Good day, everyone, and thank you for the intro again. I would frame today's session around one simple idea. Reality capture only becomes valuable when it becomes usable information. So the title is Beyond the Point Cloud and Turning Real-World Sites into Actionable BIM. So I'll keep this session practical, field-based, and focused on what happens after capture, how we move from site reality to information that AEC teams can actually use.
Mehdi, I'm wondering how should we frame today's session, and what is your background in reality capture? Can you maybe let us know more about this?
So when I started as a university student 40 years ago, so I was lucky enough to join ZEISS in Germany, and you see me the training in the Germany, and that was really a big inspiration for me to stick with the same industry as a solution provider. So I continued with the regular scanner in 1999, and you see me launching the drone with SenseFly drones, which was one of the first in the market for the mapping drones, fixed wing drones, and you see me in projects, different projects, launching the drone. And with the DJI multi-rotor drone doing the bridge inspection. And then this is the result by Bentley Systems. And then GeoSlam or First Slam came to the market. That was the invention of CSIRO in Australia. And then it was a joint commercial product first in the market. So exploring different projects, and then fast forward to when it was acquired by the GeoSlam fade out the market. I started in 2002 with FJD, and you see me in different projects. And then at the same time, I jumped to the Australia with different companies, and you see me in Australia pretty much continuing the same journey with the SLAM scanner, with the FJD. This is the substation, actually metro station, and you see me jumping to the boat in the CBD of Melbourne, and how to do creating the Revit model with the bridge, launching the drone, both fixed wing and multi-rotor drone in Melbourne, CBD. But that was really just beginning how to do the scan-to-BIM project. So I'm going to share some of these projects later on in this the next slides, and how to put together. So this shows in high level the workflow in the scan-to-BIM. So either we start with the new construction pretty much from the concept to design and construction. Reality capture plays a crucial role during the construction in terms of the monitoring and progress monitoring, pretty much. So reality capture then supports progress monitoring, verification, as-built comparison. And for existing asset, this could be path 2, where we have some existing building or asset, and this is common for renovation, retrofit, heritage, change of use, or brownfield projects, and where old drawings may be outdated, incomplete, or unreliable in both cases. A clear workflow is Pretty much the rest is the same when they just join together in terms of when we do not have reliable base maps. In both scenarios, a clear workflow is essential. So we need a professional playbook to define the purpose and capture correctly, process carefully, interpret intelligently, and the model with intent and validate before delivery. So pretty much from stage 1 to 4 is same no matter which pathway we start. The misconception here is that the scanning itself completes the job. It doesn't. The scanning provides the evidence, but the workflow turns site uncertainty into trusted deliverables. After capture modeling, we should be clear about the terminology and to be on the same page. So many people call any 3D model as the BIM, but in many scan-to-BIM workflows, the first practical output is closer to scan-to-Revit rather than scan-to-BIM, or a 3D model based on a captured reality. It starts to become BIM when we elevate the model with structure, attributes, relationships, classification, coordination, and how to federate all of those information to enliven or to enrich the 3D model that we have already created. Levels, systems, asset information, coordination, logic, and deliverable requirements, and to shape the BIM model, the real BIM model. So the model is not only the geometry, which we are creating even from the reality capture, it becomes a connected environment, connected information environment. From there, we can prepare Revit or BIM files, 2D drawings, as-built plans, schedules, quantities, sections, elevations, coordination, views, and visual outputs. Pretty much the analogy I can find here is like Uber. Just imagine that you're using the Uber and you want to move from point A to point B, and Uber did not win the game against the taxis only because of the car. It won because of the service became predictable. So it's pretty much more than in the consistency, predictable cost and time, comparing with the uncertainties, clear destination, clear pricing, expected arrival time, traceability, reliability, and inconsistent experience. So in scan-to-BIM, it's pretty much similar. Point A is our site uncertainty. So when we start from the scratch, point B is the trusted deliverables. So the clients do not really care about how you do this during the process. The client does not really want to study the engine of the car that you are driving. The algorithm or every technical steps, they want confidence that project will arrive at the right output with the right balance of speed, cost, quality, and reliability. And that's pretty much the base of the return on investment. In the process, they don't really care how you do this and how you end up there. So that's why the client is not buying the point cloud. So this is one of the typical misconceptions, that we cannot focus on the point cloud as the deliverables. So they are buying the confidence, the documentation, reducing risk, and usable information.
Yeah, I see. Actually, that distinction is really helpful. So the scan is only the starting point, and the deliverable depends on how the data is actually used, right? So what should users understand before trusting an indoor SLAM point cloud?
First point is that the SLAM is powerful, but it still depends on the disciplined field practices. So what we call as the best practices, some people call it playbook or blueprint. So they all refer to something the same. The operator actually moving through the rooms, corridors, internal spaces, while the scanner builds the point cloud in real time. But the scan path should not be random. It should be planned prior to going to the site. So we need good coverage, overlap, stable geometry, loop closure where it's possible, and awareness of the reflective surfaces. So if we can cover some mirrors, for example, or reflections, pretty much creating some false objects or some noises. In narrow corridors, we should be very mindful how to pass limited spaces or confined spaces. Open areas, moving objects, if the people walking around and weak geometry. Those are elements we need to be very mindful. One common misconception here is that the SLAM will automatically solve every field condition. It will not. SLAM can make capture faster and more flexible, but the quality of the result still depends on how the work is planned and executed. Scanner is not a magic, so it's a professional tool like a surgical instrument or like a chef's knife, but the result depends on who's using it or what purpose and what skill, how the skillful is the guy is, the operator is, and within what workflow. So it's pretty much the recipe in hands of that professional chef is really turning and transforming the ingredients to a pleasant meal. So same scanner can produce actually very different outcome depending on the route planning. So same scanner, same space, you can get different results if you do this properly or not properly. So with the control strategy, field disciplines, processing, and QA, QC, and this is what I mean by playbook or best practices workflow. Not making the job complicated, but making the result repeatable and reliable. I'm trying to highlight that when it comes to the point cloud, even the colorized, it could be very fuzzy and sometimes confusing. So this slide shows indoor space as a point cloud. So the comparison is important because a point cloud may contain the geometry, but it doesn't always provide immediate understanding. So even if colorized, as I said, the data can be noisy, incomplete, or visually ambiguous. A modeler may still need to identify walls, doors, frames, windows, pipes, ceiling elements, surfaces, and object boundaries. A useful way to explain this is the point cloud tells us where surfaces are, but not always what they are or why they matter. So this corrects a common misunderstanding here. If we have the point cloud, we already have the answer. That is not necessarily true. The point cloud gives us the measured evidence. Scan-to-BIM still requires cleaning, interpretation, model judgment, and validation.
I really love the metaphors that you're bringing. I think helps maybe people who are not that long in the industry or who are not familiar with scan-to-BIM workflows to understand what you're talking about. So I really love this kind of explanation. I think SLAM can be very powerful, but the result still depends a lot on field practice and how the capture is controlled. Building on that, how do georeferencing, control points, and visual context make point cloud data more reliable?
So even dataset could be pleasing in terms of the visualization, but it doesn't necessarily mean that it's defensible data in terms of the accuracy and what clients really need. So for indoor-outdoor projects, we can combine SLAM, UAV photogrammetry, and georeferencing. And outdoor scanning can benefit from RTK PPK as your P2 or other. For example, I started with P1 with the RTK enablement. That's pretty much really a lifesaver, time saver in terms of the georeferencing. Not only the georeferencing of the trajectory, it does some non-linear correction for the trajectory. It's not just as some fragmented GCPs to correct or align the trajectories. And that can help us connect the capture to a coordinate systems. And may reduce the dependencies on manual controls in terms of the GCPs. So this RTK PPK is really helping a lot and really cool technology. But RTK PPK does not automatically remove the need of the control. Sometimes when we want to anchor to some local coordinate system for survey grade accuracy, engineering or legal, cadastral, or contractual deliverables, project control, benchmarks, and dependent checkpoints may still be required in terms of the correction for the national elevation. So yes, we can trust modern sensors, GNSS, RTK, PPK, SLAM algorithms, but we still need verification. Checkpoints, control strategy, datum definition, and tolerance checks are what turn good-looking data into defensible data. And when we move indoors, GNSS may be lost, but the indoor and outdoor scans that are part of the well-connected trajectory, and the indoor can still remain aligned with the relatively to the georeferenced outdoor capture. So when you are on the one run and one session, no matter you lose the GNSS receiver in indoor, as long as you're connected with the outdoor georeferenced directory, you're good. So the practical message here is that georeferencing is valuable, but it must match the project's accuracy, datum control, and deliverable requirements.
How does reality capture help reduce project risk? What standards or information rules help keep everyone aligned?
The common thread here is that how to reduce and mitigate the risk and fewer assumptions, clearer evidence, and better information management. So I'm starting to be close to the subject of why we need the standards. So in construction sites like here, the reality capture can support progress monitoring, as-built verification, clash detection, and comparison between design intent and site reality. So clarity over assumptions is pretty much our goal. Progress monitoring helps teams understand whether the project is on time or on budget. When it comes to such progress monitoring, reality capture is playing a crucial role here. Depending on the frequency, could be weekly or monthly, the reality capture and compare and put in the timeline of the project in terms of the progress monitoring. So during the construction, reality capture can also help detect clashes in terms of the clash detection, deviations, missing elements, and conflicts before they become expensive site problems. So SLAM can capture floors, columns, slabs, stairs, temporary works, some piles, services, and internal areas. UAV photogrammetry can add on the rooftops, facades, so whatever which can be easily visible from the ground can be covered on rooftops, for example, and stockpiles and top-down context. So from two different perspectives, we can pretty much cover with SLAM, UAV, GNSS, 3D 60 imagery, GCPs, and checkpoints are all valuable ingredients. But ingredients are not the meal, as I already touched on this with that analogy. They need the right recipe and the right sequence and the right professional judgment to transform raw site data into a useful deliverables. Because eventually we are looking for some useful deliverables for the clients. And a good chef does not only know the ingredients, they know the customer's taste as well. So in our world, translation could be that the understanding of the scope, purpose, accuracy requirements, deliverable format, budget, timeline, and expectation. Before modeling, the data must be prepared. That means that checking coverage and cleaning noises, aligning data sets, simplifying and resampling where appropriate, and creating a model-ready data set. The practical point is simple. More data is not always better. Fit for purpose, validating data is much better. So when we only look at the point cloud, we can lose visual context. In the background, you have a point cloud, even colorized. You may know where something is, but not always what it is. So colorized point clouds help, but they are not same as high-resolution 360 imagery. A 360 panorama helps identify materials, fixtures, doors, windows, frames, switches, pipes, all elements, you name it, ceiling elements, MEP, mechanical, electrical, piping components, and object boundaries. And this is especially important when the modeler was not on site during capture. The principle is simple and worth remembering. Point cloud map, geometry, panorama restores clarity. And when it comes to the AEC scan-to-BIM, that is why 360 imagery should not be treated as decoration. It is a part of the interpretation, communication, and quality review. So that brings me to the standards here. This slide positions reality capture within LOD and information management. These two frequently used terms in the BIM standards. So LOD describes how much model details or development is required. So LOD stands for level of details or sometimes level of developments. So for many scan-to-BIM workflows, reality capture commonly supports
LOD 200 and 300. So we are normally sitting in this area of LOD 200 and LOD 300 in terms of the geometry and details we capture, and sometimes we touch a little bit in the area of 350 in terms of the relations, but not pretty much. But everything beyond that is pretty much depending on more office works, how to build up the LOD 400 and 500 in terms of the more details, which is beyond our capabilities or instruments. So it supports, as I said, LOD 200 and 300 modeling, depending on the required accuracy, level of interpretation, and project specification. A common misconception here is that using the laser scanning automatically means the model LOD 500, which is not true. So reality capture provides evidence. It does not automatically define the LOD. LOD depends on what is modeled and how it's modeled, what information is attached, and what tolerances are required, what the client has specified in terms of the deliverables. A point cloud is not a certificate of LOD when the modeling scope and information requirements are clear. So now a few words about the ISO 19650, which is often misunderstood. It is not a geometry standard. It does not define LOD. It is an information management framework. It's actually a common language in the industry, and to align the different teams and they can speak in the same language to be on the same page. In simple terms, this ISO 19650 gives the BIM industry a common language so different teams and stakeholders can stay aligned, speak consistently, manage data properly, and control revisions, and stay on the same page across the project lifecycle, as I said. So the distinction is LOD defines expected model development. ISO 19650 helps manage the information process. Accuracy and tolerance still be specified separately.
I think here we can maybe summarize that it is not only about capturing more information, but also about reducing basically assumptions and also the customer expectation. I think here that's a very important point that you're making, that we need basically to manage the expectations of our customers and our clients for a certain job. But then if they don't understand basically the details that you were just describing, then even a good product can cause some customer dissatisfaction. Right. And here I would also like to ask a question. So could you please maybe show us how these ideas work in real project examples across different site types?
And yes, this example shows a mixed reality capture workflow that I just had in the Queensland, Australia, in Sunshine Beach. So the sequence starts with the aerial capture. I did the UAV. I had the M4E from DJI. The multi-drone photogrammetry provides the high-res images from the air, covering the roof, facades, site context, and top-down geometry. And then the ground and indoor areas are captured using the SLAM scanner. So as soon as I land the drone, I start the capture with P2. This is the P2 in my hand, and this adds a close range ground level point cloud. It's equipped with perfectly with the 360 camera X5 on P2, and that gives us the best of both worlds. So the drone sees what the person on the ground cannot, and the handheld scanner sees what the drone cannot from the air. So the third dimension of clarity comes from the imagery, high-res images from the air, and 360 imagery. And you see that both point clouds from the air, and in this video showcasing that the point cloud we get by drone starting to sit on top of everything. So the red one, which is coming down, is from the drone and sitting on top of the yellow one, which was the result of the SLAM. And blended those can give us very ideal situation. Then we start to do the reality to Revit modeling, which to replace that fuzzy point cloud with very clear and crispy 3D model, as I visualize here with the Twin Motion, a product of the Autodesk. You see that the result is very clean model, and we start to extract some deliverables. So we start to do some extraction in terms of the sections, verticals, could be floor plans, and that's the end of this story that I just shared from Queensland in Australia. So the next slide is actually providing more visuals about in terms of the 360 images. So feel free to scan this QR code by your phone, and you can even switch between point cloud, colorized point cloud to the visuals, and you can also start to measure things. You can start to measure distances, angles, areas, and navigate the whole site. And this is really a cool deliverables. When it comes to the actually clarification, it's really crucial product when you start to build up the Revit modeling. So this is not just a visual extra, it's a communication and verification layer. The virtual tour lets remote stakeholders stand in the same digital room. So they may not be on site, but they can still inspect, discuss, and understand the captured environment. So for modeling, it reduces assumptions. So rather than just imagining that, okay, that's very unclear that how I should model this element, for example, they just jump to this virtual tour with full visibility, with high resolution, and immediately have a better understanding how to connect the dots and to come up with a good understanding. It makes the captured site easier to understand without needing specialized point cloud software. And that brings me to the next story. This example is Melbourne townhouse renovation workflow. First, the site is captured as an indoor scan, and you see that this puppy, playful puppy, is around me. And the scan includes the building, interior, exterior, garden, access area, and surrounding. And this puppy is sticking to me, perhaps very curious what I'm doing. So during the scan, the real-time point cloud is visible on my phone. You see that the phone attached to my wrist. And this is important because we can check coverage on the fly. So while we're scanning on the side, not after we return to the office, which is like a nightmare. So then the process point cloud appears. At this stage, the site is no longer just a collection of the rooms. Next, we can view the data, and then modeling process begins. Walls, floors, doors, windows, as you can see, other elements are interpreted and converted into structured BIM geometry. So we start with a real site, capture it in the field, check the evidence, process the point cloud, interpret the geometry, leveraging those 360 imagery and virtual tour, and then we transform it to a very clean model, as you can see, like this one, and that can support renovation, planning, documentation, and the scan captures what exists, and the workflow makes it usable. Because clients do not really care about the process. And you see that in the virtual tour, if you scan this QR code, again, you end up yourself in this same environment that I'm just showing up here. You can measure everything, even from the virtual tour. So in the back end, there is a geometry connected to the point cloud in terms of the georeferencing, and you can literally immerse yourself in the environment and start to explore and play with it. It's like a game changer, this way of doing things, and really, really enjoyable, of course. So the next story is the slide. The purpose is to show the workflow is not limited to one limited type. Scan-to-BIM can support residential renovation, commercial buildings, construction projects, infrastructures, industrial assets, underground spaces, and complex environment. And you see that the Revit model is the result of the scan-to-BIM process. Technology may change from subject to project, but the logic remains consistent. Define the outcome, capture the site, clean and align the data, and interpret the evidence, model the required elements, and validate the results, and deliver what the client actually needs and looking for. So the reality capture is not one push a button. The button may start the scan and just the beginning of this journey. So, but the workflow creates the result. Reality capture becomes valuable when it is connected to a clear deliverables.
That's a very practical way to see how the same workflow changes depending on the site and the final deliverable. Thank you for sharing these examples. And so once those examples are clear, how do we move from captured evidence to a trusted deliverable?
So I little bit break down this part, how we make sure that in terms of the defensible data, what we deliver is defensible, and it really protects and elevates our reputation, because we need this for our marketing purposes, right? So at this stage, the focus shifts from the capture to delivery, evidence, interpretation, modeling, and validation, pretty much. I try to highlight again the steps that we are doing. So here we do the capture, and then we leverage the tool that I just discussed, that 360 imagery, how it provides the clarity. And we can even leverage the VR headsets, as you can see, or by naked eye in front of our display. So we literally in the space, we can measure things, we can have a better understanding, we can do a better interpretation, and we end up with start the modeling. So a common misconception here is that software will automatically create a correct BIM model from the point cloud. Automation can help, but modeling still requires human judgment and project requirements, classification, interpretation, and QA, QC, quality assurance, quality control, pretty much. The modeler does not necessarily need to be on site, can be very far. Even the operator who was in the site cannot maybe remember all details, but they need enough evidence to make reliable decisions. That is why point cloud and 360 imageries work together, and very important. And capture is one step. Delivery is a sequence. Evidence, context, interpretation, modeling, checking, and final outputs. Each step adds a value: evidence, clarity, structure, validation, and delivery. So let's get to it with more breakdown, how we do this in terms of the validation. So again, back to the modeling part. And this slide shows how we validate the model. And QA pretty much defines the rules before the work even starts. Required accuracy, LOD, deliverables, tolerances, review process, responsibilities, approval method, how we're going to approve this. These are pretty much part of the QI as QA. It provides us the actually guidelines how to do the project itself. And the QC is the actual checking process after modeling. So after we finish the modeling, then it could be in-house, it could be outsourced by any team. So we compare the BIM modeling against the point cloud and 360 imageries. In the scan-to-BIM, QC checks the misalignments, missing objects. Normal typical problems is that the wrong elements, misplaced features, missing pipes, wrong interpretation of the operator, and completeness the issues. So we report back after we are flagging those problems, and then goes back to the BIM modeler to correct those or complete those. So the BIM model is the actually structured conclusion for developers, designers, contractors, and owners. Mistakes can be very unaffordable because it's putting your reputation in risk, it's putting the next teams in risk. So missing pipes, wrong wall positions, misread openings, or inaccurate level can create really big cost, delay, and reputational risk. So QA/QC is what makes the deliverables defensible. It helps move from it looks right to it has been checked against the evidence and project requirements. It's verified and it's a proven deliverable. So this loop, as I said, is what turns a clean-looking model into trusted deliverables.
I'm also wondering, so what practical approaches can reduce workflow friction, improve accuracy, and make the process more reliable?
And this is where where workflow efficiency matters. So because every disconnected step can add rework and assumptions, this slide explains a major shift in architectural and BIM documentation workflows. And traditionally, many projects start with 2D drawings, floor plans, sections, elevations, and manual drafting. A 3D model may then be built later from those 2D drawings. This is on the left side, you see this traditional working from 2D to 3D. But that workflow can create friction. if the design, just imagine that if the design changes, and which is pretty much likely, so drawings and models may need to be updated manually, and which increases rework and the risk of inconsistency. And just imagine if you just have to redo the old 3D model part, and that's really a nightmare and very tedious job to do. So in a BIM first workflow, which is on the right side, so this versus 2D to 3D versus 3D to 2D, on the other hand, we build a 3D model first and then extract 2D outputs, sometimes automatically. From that model, floor plans, reflected ceiling plans, sections, elevations, and documentation is normally just an automatic extraction done by the software. So it's just a section, no matter which direction, vertically or horizontally. So it's safer to maintain one coordinated source of truth, and when the model is set up properly, the changes can flow through the outputs more efficiently and much faster. And so the direction changes instead of building 3D from disconnected 2D drawings. We use the 3D model as the coordinated source of truth. This is just a new approach. This slide shows how the software integration can reduce workflow. Thanks to FJD team, which was smart enough to build up a plugin on top of the Trion model software. So the fewer disconnected steps we have, the easier it is to check, revise, and coordinate. The goal is to reduce the unnecessary handling, keep the evidence visible, and make modeling and review more efficient. In simple terms, fewer disconnected steps, fewer assumptions, faster revision loops.
What do you think are the main takeaways people should remember before starting a scan-to-BIM project?
So first, scanning is not delivery. Starting a scan begins the workflow. It doesn't finish the project. Reliable outcomes depend on planning, operator skills, and processing and validation. This could be one of the first takeaway, for me at least. The second is point cloud is not the deliverables. And sometimes it's really a big mistake if you deliver the point cloud to the clients, which some of them are really hating this because they know that they can do nothing with it. So it is the raw capture and evidence layers. So what they expect is value, which is value coming from the cleaning, interpretation, modeling, and checking. This is where the real value is. The third is more data does not automatically mean better data. Clean, aligned, fit-for-purpose data is more useful than a large, noisy data set. So fourth could be one sensor does not solve everything. So that's why we have a stack of different techs and gadgets, SLAM, TLS, UAV, you name it. So the right stack depends on the project and pretty much the scope. The fifth takeaway could be colorized point cloud do not show everything. 360 images, especially in those complex environments, really restores the context and clarity, especially for interpretation, modeling, and remote review. Sixth takeaway could be a clean-looking model is not automatically a trusted model. Doesn't necessarily mean that. QA/QC catches gaps, misalignments, and wrong interpretation before delivery, and that's really some kind of insurance to protect your reputation before delivery. The seventh takeaway could be not every 3D model is a digital twin. This is really a big misconception I hear a lot. And to demystify this misconception, I can tell you that a digital twin begins when the model connects to the live and regularly updated asset information. So before you put some IoT sensors, so environmental sensors, and you provide the live data on your dashboard for stakeholders, you do not really end up with the digital twin. So the misconception is that they just call the reality capture, even the BIM model, as the digital twin, which is not. So the final message here is very simple. Reality capture is just the beginning. It's not the destination. The goal is not just to scan faster. The goal is to capture, clean, interpret, validate, and deliver information people are really looking for and can trust.
Yeah, thank you very much, Mehdi. And I think that was a very practical walkthrough of how reality capture becomes valuable when it is connected to different workflows, to different interpretations, validations, and of course, final deliverables. And also, by the way, if you have a workflow that you would like to share in one of our future webinars, we would be happy to hear from you, because innovation grows when people share what works, and great workflows deserve to be seen. So we look forward to seeing you at our next webinar, and see you next time. Have a great day.